Welcome to theme 2, where we now get down to the business of doing research. So how do you plan and design a research project? So most of you would like to know why start. It always starts with a problem or a question, something that we observe about the world. And then you say, I wonder what is it about this? How does this work? Why is this like that? What is going on here? And what if I change this? What will happen? So it's when we look at finding a topic in the real world, we do this by observing things around us, or you can look at a practical real life problem that you get from your work or something that you see in the media. You can get it from previous research, from books or journal articles or research reports, and all of these in their conclusions would usually state what is further research that needs to be done. And that's, if you're really stuck, that becomes a very good place for you to find your own research problems, is to see what other people have identified as work that needs to flow from their particular studies. We can also find a topic from our theories in terms of trying to prove or disprove or test a theory, or to resolve conflicts between different theories. But the main thing, and this is the most important thing, it must be something that interests you. Because if it doesn't interest you, it becomes very difficult to keep the motivation of going on with your study and doing the work. People have been trying to find problems for a long time, and people get sometimes really silly problems. This guy, John Tronkaus, built his whole career out of doing research about things that annoyed him. So he would do studies on silly things like what percentage of swimmers swim laps in the shallow end of a pool rather than the deep end, or which percentage of drivers almost but not completely come to a stop at a particular stop sign, and one that we all hate, and that is which percentage of shoppers exceed the number of items that's permitted in a supermarket's express checkout line. Now these are all silly things, but what about these? Why do people cringe at the sound of fingernails scraping across a blackboard? Silly. Will humans swim faster or slower in syrup? Do chickens prefer to look at beautiful people? Or what is the surface area of an elephant? All of these are Ig Nobel Prize winners. Now, the Ig Nobel Prize is a prize that is given for research that makes you laugh and then makes you think. In other words, it is still valid research. So these are the contributions that these particular papers have made, and you can see that each of them are grounded in a particular scientific tradition: psychoacoustics, computational fluid dynamics, done in the Journal of the American Institute of Chemical Engineers. I'm not quite sure how whether we know that chickens prefer beautiful humans help us, but it is published in an accessible and a recognized journal. And the same with the trying to figure out how big an elephant is. Now, let me give you an example of something that may look like a silly problem, but that actually, because it is grounded in a particular scientific tradition, it makes a huge contribution. What happens here is a number of researchers sat around a dinner table one night, and they looked at how the tablecloth was falling over the table. And they said, well, they wonder how this happens. So what makes a flat sheet of fabric forms these particular folds? So they then formulate the research question is, what determines the shapes formed by draped fabric? Wrote a paper about this, which was published in the Proceeding of the National Academy of Science, which is one of the world's top journals. And why did they get such a silly paper into the Proceedings of the National Academy of Science? Because it made a huge contribution. It contributed to the theoretical basis of complexity theory to show that small causes can lead to large effects, also as valid for the field of geometry. It contributed to the theoretical basis of geometry by providing ways of calculating and predicting unusual shapes. So it's applied science here. And then its further application is then where it used experimental development using these theories in terms of fashion design or computer animation and virtual reality, for example in movies like Avatar. Our second example is even stranger. This was a phenomenon that was observed by a Japanese artist who spent his 6 month stint on Marion Island, and he looked at all these penguins and said, well, but they make these wonderful splatter patterns around their nests as they poo. And again, I'm sure this happened over a glass of beer or two. The scientist starts asking, but how do these things form? And the eventual question they developed was, how much pressure builds up inside a penguin when it is defecating? And the science here is the science of fluid dynamics. Paper again was published in a highly respected journal. And what is the contribution? Because knowing the diet and how far, because of the pressure, so how far the poop would span, it helped save the vultures in Africa. Because what happened is people were realizing that vultures were being electrocuted on those those high power lines. But they couldn't figure out why, because the lines were far enough away that even if the vultures opened their wings, they would not be able to touch the wires and therefore make a circuit. And what happened though is that the vultures would sit on the power lines, they would defecate, and in that moment it would create a circuit and the vultures would be electrocuted. Understanding this and being able to calculate what that arc would be of the feces going out of the vulture, they could then redesign the power lines to avoid this problem in the future. It is also used to calculate the sort of safe distances between enclosures and visitors in zoos so that they don't get pooped on by birds. And it helps us also in the science of paleontology, where understanding the splatter patterns around dinosaur nests help us to understand dinosaurs as well and the diets of dinosaurs. But the important thing here is that all of these purposes understood the scientific context that they're working with, and they worked within a particular theoretical domain. So, look, for example, one of the research fields that we would be working in, which is economics. Within this, you have a particular set of theories, and one of these theories are the group of theories around valuation. Out of this, we now get a theoretical domain for your particular study where we look, say, at mass valuation techniques, and we identify research topics. What would be mass valuation models for agricultural land? But this topic is not yet a research problem. How do we move from a topic to a research problem? We have our vague idea, which is our topic. We then need to narrow it down so that we can define a problem and from which we can then formulate our objectives, our hypotheses, or our research questions. So when is a problem not a problem? We have real life problems and then we have research problems, and they're not the same thing. A real life problem we can solve through taking action. A research problem we solve through asking questions. But our real life problems help us to define research problems, to define then those questions which will help us to come to an answer which eventually will help us to solve a real life problem. So what is a research problem? We usually find our research problems in areas of conflict or where there's some concern or some controversy between different theories, or where there is a gap in knowledge about a particular phenomenon. But it's important to understand that your research problem is not your question or your hypothesis. It's the reason why you are asking the question or the reason why you are formulating your hypothesis. So how do I now identify the problem? Again, we look at background research. So you would look, you've got a topic. You've got your idea that you picked up from what you've seen or what you've read in the newspapers or a particular issue at work. Now you do a bit of reading about it and you talk to experts in the field to find out what is the particular problem around this topic. There are many problems usually within a particular research topics. So what are the burning issues? What are the gaps in knowledge? And very importantly, you have to also ask yourself what it is that I can do. What are my skills? What kind of access do I have to data? And how long will it take me to take this particular study? Understand, for your mini dissertation or for your research that you're doing, you have a set time, and usually the university allows you 2 years to do your master's degree in, 3 years for a PhD. So your study will have to be able to fit into this particular time frame. And then you have to ask yourself, is my problem actually motivated? Does it flow from the motivational argument that precedes it? And how valid are the assumptions on which this particular argument is based? So once you've been able to answer all these questions for yourself and you've now gone through an iterative process of refining and clarifying your problem. So, for example, our topic is now mass valuation models for agricultural land. There's many problems that sits within it. For example, there's no mass valuation model for agricultural land. But we can further refine it. Are we looking at all kinds of agricultural land? Are we only going to look at a particular large-scale commercial farms? Are we looking at small holdings? Are we looking in South Africa or are we looking sub-Saharan Africa? A second potential problem is that there are some barriers to the acceptance of a mass valuation model for agricultural land. And there can be a number of barriers like legal, social, political, or simply data barriers. A third potential problem is that there may be existing mass valuation models for agricultural land, but that they are perceived as inaccurate. So you can see already we have 3 problems. But we can further refine this. So how do I know I have a good problem? It's something that we can answer, so it can be done within those limits of time, of cost. Remember, all research is going to cost you some money, and the availability of data. And this is usually the most difficult thing, because people are very wary of handing out their own data. And so if you have to rely on the data of companies, this may become an issue for you. It's a legitimate problem, so it's not just an exercise in gathering information or learning more. It doesn't just answer a simple yes or no question, and it doesn't just make a simple comparison between data sets. So there's a level of complexity to this problem. And thirdly is that by solving this, you will make a contribution to the world. You will add new knowledge, you may provide important and useful answers that will help us to solve real world problems. And also that it is unbiased. It does not set out to prove a particular point of view. And we get this quite often, that students have a bugbear and they want to prove that they are right. So they come into research with this notion of proving their point of view. And that is not what research is about. Remember, it's about being objective. So now, how do I narrow down my problem? Which aspect am I going to investigate? So if we looked at our problems that we identified earlier about the barriers to acceptance, we can do all of these, but that would be a PhD. Or you can look only at social barriers, or only at legal barriers, or only at political barriers. So now you can start narrowing down further, and you can define it even further down, where you scope it through what we call delimitation. So there's always a section in your study where you write about the delimitation. There's the limitations to the study, the things that limited the generalizability of your study or the validity of your study, and then there is the delimitation, which is the boundaries around your study. And we can delimit our study through, for example, time. So you have a particular time period, or it's situated in a particular place, or you limit it to a particular scale or group, and you try and get a clear purpose that further defines your problem. So what it is that I want to achieve with this piece of research. And once you are able to write that down in a clear sentence, you have a research problem. But the key here is to be as precise as possible, because any ambiguities and uncertainties and open-endedness in your problem statement is going to create problems for you in research. Now you can test yourself a little bit about whether you understood what we explain now. On ClickUp there is an article. Download it, read it, and then do your exercise, which was to ask for yourself, out in this article, what was the phenomena that the researchers observed? What aspects of this phenomenon did they decide to study? So how did they scope the study, and what was their final research problem? We're going to use this particular little paper to illustrate a number of the concepts around research planning and design in the future.